Hi, I'm Professor David Farina. In today's lecture, we'll be discussing the Sun, our star, in particular the Sun in bulk. Let's get started. So what do we mean by the Sun in bulk? What we mean by this is, what is the Sun overall in terms of its properties, in terms of its composition? So in terms of its radius, it is 696,000 kilometers across. Now, this really doesn't give us a whole lot of perspective, but one of the things I think is helpful to think of is the fact that 100 Earths could fit in terms of the diameter of the Sun from one side to the other. These sunspots here, you could easily fit the Earth inside of one of them. 1 million Earths could fit inside of the Sun in terms of volume. So it's a pretty big place. Now, in terms of stars, it is an average star in some ways, but for the most part, it's a pretty small star. Many stars are much, much bigger than the Sun, and some are much smaller than the Sun as well. In terms of mass, it's 1.99 times 10 to the 1,030th kilograms. This is just, once again, beyond perspective. It makes up an enormous percentage of our solar system, over 99%. So it is the bulk of our solar system. Its average density is 1,410 kilograms per cubic meter. Once again, this is probably a number that is well beyond our normal thought process. 1,410 kilograms is equivalent to a mid-sized to large SUV, and it's packed into an area approximately the size of a normal-sized microwave, normal-sized oven. So if you look at that and consider if you could compact the mass of your car down into the size of your household oven, that would be approximately the average density of our Sun. Rotational period, it rotates every 25 or so days at the equator, but it rotates more slowly as you go higher up towards the poles, with the poles being a 36-day rotational period. And its surface temperature is about 5,780 Kelvin on average. This is about 10,000 Fahrenheit or so. And the surface luminosity is 3.86 times 10 to the 26th watts of energy, which is an enormous amount of energy, well more than all of the amount of energy that we produce or consume here on the Earth's surface, which makes the Sun a wonderful means to get free, clean energy in the form of solar panels and wind. Now, overall, the Sun is going to have multiple different layers. The core being about 200,000 kilometers in size. Once again, way, way bigger than the Earth. The core, by the way, we'll get into more detail later on. But that's where all nuclear fusion takes place. Then we have the radiative zone, the convective zone on our way out. Then the photosphere, which is actually what you would view when you're looking at the Sun. The chromosphere is outside of that, and then the transition zone, and then finally the corona, way out on the very edges. Now, the Sun's overall luminosity, of course, is radiated in all directions, 360 degrees, and the Earth only picks up a fraction of that amount of total energy, which is equivalent to about 4 times 10 to the 26th watts, or about 1 billion megaton bombs per second. And those are nuclear bombs. So 10 billion 1 megaton nuclear bombs per second is quite a large amount of energy. Once again, if we could receive all of that sunlight and convert it into usable energy here on Earth, we would have a tremendous amount of energy to work with. So the solar panels on Earth's surface are a great means by which we could get a clean, free energy over time. So thanks a lot for watching this video of the Sun, our star, and the Sun in bulk. If you like this video, please check out the channel by subscribing. And if you could please like this video, and if you'd like to get more notifications about future videos, click the little bell at the bottom. Thanks again, and have a great rest of your day.